You'll do it on your test, won't you? You'll do the same thing. We're just going to get this z-score for that gentleman right there, and we're going to get a z-score for this woman right here. And whoever has the higher z-score is the answer. Now, if it's a tie, we'll just have to say they're equal and it's a tie, right? That's what we'll do. They come out numerically the same, because that could have happened, true? They look pretty close. All right, let's do it. Everyone, let's get the z-score for the man. That z-score, we know it's going to be negative, but it equals, all right, what goes right here? What was his height?
67.
67. What was the mean? 69.6. Divided by a?
3.
3. Awesome.
I just have to take an absolute value?
No,
No?
because z-score is going to be negative.
Oh, really?
Yeah, z-score is going to be negative. Hey, everyone, I'm going to do this on purpose. This is the professor mess up, right? On purpose. Because I don't want you to do this on your test. Or practice problem. There, all right, I'm getting the z-score. Can everyone see that? Is it showing up? Everyone see it? What's wrong? What's wrong with this? I'm saying, don't do this.
Parenthesis.
Look, I'm just typing it in. I'm going to get my z-score. Don't do this. Order of operations, right? What is it? What happens in order of operations? It does what first?
Division.
Multiplication and division before the addition and subtraction. So how should I type this in? I heard it. Someone said
Parenthesis.
parentheses. I heard it. So I'm going to just clear this out. This should be wrong. I need to put, if I do it all at once, parentheses 67 minus 69.6. Close the parentheses, division of, was it 3? All right, and I'm just going to go out to a couple decimal places. 2 decimal places. Z is roughly, roughly about negative 0.87. Okay? Yeah. Now, and when would you get the z-score for the woman? What was hers? She was 62?
Yeah,
And when she
0.5.
was 62, he was 67. 62 minus, now be careful, don't use the mean of men. Use the mean of women. 64.1, and what was standard deviation?
3.8.
You know my rule. I want one person to get it, and then someone else will double check.
Negative 0.55.
Negative 0.55. Can someone verify that? Is that what you got?
Yeah.
Awesome. Thanks, Holly. Everyone. So Helen got it, Art got it, negative 0.55. No. We got the numbers. We gotta be careful though, everyone. Negative numbers are tricky. Which one of these 2 numbers on the board is actually higher? Which one is closer to that?
The one on the right.
Yeah, this one. We gotta be careful. Gotta be careful with the negative values. This one is actually a little bit greater than that. So this is the winner. This is the answer to the question. So when I answer this, I'm gonna say the woman, the 62-inch tall woman. So if these 2 are dating and they are having this argument, I mean, yeah, she wins the argument. She's like, we're gonna use statistics, right? She wins. Hey, on a test, yeah, on a test, if these came out to be both negative 0.55s, then say they're both the same. They're both the same relative to their populations. Hey, so with statistics, what's very important, understanding what all this stuff means, being statistically literate. So I want to make sure you understand z-scores again. You're like, all right, that's a z-score. And that's, and you go, what does this mean? Let me say it with words again. You go, what does that mean? That gentleman right there is negative 0.87, listen to this, standard deviations below the mean. He's close to 1 standard deviation below the mean. So he is 0.87, let me say it again, he is 0.87 standard deviations below the mean. He's close to 1 standard deviation below the mean. By being negative means he's below. When it's positive, where are they? Above, right? Yeah, so this woman right here, she's roughly close to 0.5 standard deviations below the mean. So when I'm saying this with the z-score, I'm saying 0.55, then I'm saying what? Standard deviations, right? Sometimes people don't understand what a z-score is. They think it's like a percent. No. It just represents position, right? Position. You're 1, you're 2, you're 3. Okay. You were at negative 0.5, you were located right there. So, cool. So let me throw, I'm gonna give you a question. I want to make sure you conceptually understand this concept of z-score. Okay, can I erase? All right, so I'm gonna erase. I'm gonna give you a story while I'm erasing. Everyone, I went to the doctor yesterday. Oh, Liz, go right ahead. I'm sorry.
Is this always going to be, this z-score always going to be a comparison between two things?
Not always just a comparison between two things. It's going to allow us so many cool things in this course in the world of statistics because it gives us position and there's so many distributions that are what? Bell-shaped. If you and I look at this and we think, well, this area under this curve, this is what we'll get to later in the course. If the area is 1.0, we can think of that as 100%. And then we look at like probability of things occurring. We can talk about the likelihood of things happening. We really can. We can look at chance. Like, what's the chance this could happen? And you go, well, how are you going to get it? We'll go, get the z-score. We'll see where it is, and we can look at percentages inside these bell curves. Cool? But that's coming up, and when we talk about that probability word. You know, when we get the probability to chapter 5. We don't want to rush everything right now. Right now we're just doing position, true? Awesome. Hey, I know for right now, the only percentages we know, Liz, is that 68% of data is within here, 95% of the data is within here, and then 99.7% of the data is in here, and then you might have someone like Shaq who's over here with a height of 7 feet tall, right? All right, here's my story, everyone. Oh boy. I went to the doctor yesterday. You know, annual checkup. Checks me out, blood work, all that. Well, something kind of alarmed him, everyone. It was my cholesterol level. And he says, you teach statistics, right? And I said, yeah. And he goes, it's your cholesterol level. I'm like, oh boy, what? He goes, well, relative to men your age, he goes, your cholesterol level, your z-score is 2.0. Okay, so did everyone hear me? I'm going to give you an A, B, C kind of multiple choice question. I want you to tell me which one of these is the correct interpretation of that. He knows I know because I'm a stat teacher, right? But did you hear what he said when he talking about my cholesterol level? My cholesterol level relative to men my age? And he gave me my z-score after doing a test. And my z-score was what? 2. All right, so letter A, is it this? Is this the right interpretation of that? And when I'm 2 percentage points above all the other men my age? Is that what that means?
No.
No, that's not it. That's not what that means. Okay, he said I had a z-score of 2. Does that mean I'm 2 points? I'm 2 points above men my age? 2 points? No, that's not what it means. All right, letter C. He said I had a z-score of 2. Does that mean I am 2 standard deviations above the mean cholesterol level of men my age? Ding, 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 ding. That's what it means. And you can almost make a picture, right? In your mind, you got this bell, and I'm over there, right? And high cholesterol, not so great, right? You're like, hey, you're something. By the way, I'm lying. I'm making up this story. Although I should check it out, right? I should check it out. So that was the answer, and you're right. I mean, you're making a picture like you're right there, and that's not good. You know, maybe if these are like scores on an IQ test, oh great, yeah, that'd be super. But no, it was. We were talking about cholesterol level. It's pretty high. I'm way over there. All right, so very good with that. So those are z-scores. Deals with position. But there's other ways to look at position. What if the data is not bell-shaped? What if it's skewed? And so we're now going to look at what's called a 5-number summary. We're going to look at a 5-number summary. But when I talk about 5-number summary, everyone, would you get outside a bell-shaped? It can be bell-shaped, but it doesn't have to be. I'm talking about a 5-number summary. This distribution can be skewed left, skewed to the right, or bell-shaped. All right, so the 5-number summary. There's 5 key statistics. What are they? The min, or the minimum. I'm abbreviating the minimum. Everyone in a distribution, that's going to be the lowest, right? All right, now put Q1. Yeah, Q1, I'll talk about that in a second. The median, I'll just put MED for median. Q3. And the maximum, I'll just put max to abbreviate. And when you say I wrote Q1 and Q3, Some students like to write those like this, like a subscript, if you like to do that, but it doesn't matter. It doesn't matter in terms of notation. Put a Q3 right next to it, or a Q with a 1 right next to it, I'll leave it like that. All right, so we're gonna look at a distribution, and you and I will talk about, well, what the heck is the Q1 and the Q3, and what does that represent? All right, we'll talk about that in a second. We'll get some numbers here. Get some data off the textbook. Who's got their textbooks? We'll get the data from the textbook. We'll use you okay using calculator to do this? All right, we'll use technology to calculate these values, and we'll talk about what it means. But before I do, how about by hand, if you wanted to do this by hand? Some students like to do everything by hand. We know how to find the minimum. Wouldn't that be the smallest?
Mm-hmm.
And when you know how to find the maximum, yeah, that'd be the largest. Now, do you recall from the last test, do you know how to find a median?
Yeah.
Okay, good. So what is this thing right here, the Q1? This would be the middle number between the minimum and the median. That's what it is. Q1 is the median between the minimum and the median. That sounds funny, doesn't it? But it's the middle number. So if you want to do by hand, list all these, sort all these, ascending or descending order, and then go find what's the middle number. And guess what Q3 is? That will be the middle number between the median and the maximum. And you'd sort them. You could do it by hand, but please feel free to use technology.
So median
Okay.
is Q2 because I've seen people.
I love it. And hey, we got a new name for median. We can now call it Q2 if you want. You don't have to, but you can. You can call it Q2. Let's put some other names down. I keep saying Q1. You're like, what is that? It's called a quartile. So this is the lower quartile. Let's get some names down. You're the lower quartile. Q1, the lower quartile. So you, Q3, you're the upper quartile. Upper quartile. Lower quartile, upper quartile, Q1, Q3. Hey, here's some other names. We said this represents position, right? We can talk about percentiles. Now, I'm not drawing a bell because the data might be skewed, true? So I'm not drawing a bell. You might have skewed data. Maybe the data went like this. But we're like, where's something at like the 50th percentile, the 25th percentile, and all that stuff. And when we can call Q1 the 25th percentile. What do you think the median is?
50th.
You can call the median the 50th percentile. You go, really? Yeah. You know why? Half the data's over here and half the data's over there. It's the middle number. What percentile do you think you got here?
75.
The 75th percentile. And I guess the max would be represented by the
100.
100th percentile, right? We don't have to write that. But yeah, like the max. Yeah, you're the max.
So
You're the highest.
percentile doesn't just only detects the position, not the number. So 87%. So somebody can have a score like 75 in the
That's
test,
right.
but it could be 87%.
Mm-hmm.
Okay.
Very good. All right, I'm going to get some data. We're going to go to a data set in the book. If you don't have your textbook, no problem. We'll just write down the page where this data is from. Let's use technology to get these 5 numbers. Although I think we won't have any problem getting the mean, the min, and the max, right? And when I was looking at this today, and I thought, here's a good problem. It was on page... Give me a sec. Where did I see it? It's actually on page 175. So when I'm now, it's funny. Page 175, I'm going to use the data set. Can I erase the material on the z-scores? Are you sure? Awesome. Because we're done with z-scores for the day. We're done with z-scores for a while. Because now we're getting into data that's skewed left, skewed right, or it could be bell-shaped. Doesn't have to be. And when I'm going to use this data table, and there's data here, now this represents the data shown in table 17 shows the finishing times of the men in the 60 to 64-year-old age group in a 5K race. So in 5K race, anybody ever run a 5K? It's like 3.2 miles. But how old are these men? So don't make fun of their times. Don't be like, man, they're slow. Because they're like 60 to 60 years old. I'm shocked they're even running at that age, you know? I'll be just sitting on the couch. Right? So it's pretty good. All right, so here's the numbers. It's on page 175. I could write them on the board. How about I just type them in the calculator? If you don't have your book, you can type them with me. We're going to put all these in L1. All right? We'll do this. It won't take too long. Do you need me to hit the lights? It looks a little better, right? I'll hit the lights, everyone, just so if you don't have a textbook, you're like, can you just put those numbers in there for me? I'll type slow too, but it won't take that long, everyone. Few men ran in this race. I'm going to go to stat and hit enter. Oh, I got to clear this out. You know what I do? I up arrow to L1. I hit clear. Don't hit delete. And hit enter. There we go. All right. But here's the first time. 19.95. Wow, that's pretty good actually. Someone busted 20 minutes, age 60 to 64. That's impressive. That's pretty good for 5K. I'm going to go, gosh, they seem sorted all over the place. I think I'll just go by the columns. So 19.95, 28.58, 33.23, 23.25, 28.72, 33.53, 23.32, 30.18, 36.68, 25.55, 30.35, 37.05, 25.83, 30.95, 37.43, 26.28, 32.13, 41.42, 42.47, 49.17, and then ouch, 54.63, that would be me. Close to an hour, right? 54 minutes, 54 and almost over a half a minute to do the